Okay, section 7, not included in exam 1, interpreting change. So we have absolute change, which is just a new value minus an old value. For instance, say a candy bar cost $1.50 today, but it used to only cost 50 cents. Well, that's $1.50 minus 50 cents. That's $1 absolute change. So it's changed in value of $1. That would be the absolute change. That would be a positive change or an increase. It's increased by $1. Relative change is the absolute change divided by the old value. So in our case with the candy bar, that would be $1.50 minus 50 cents. That's $1. So it'd be $1 divided by 50 cents. And that would be the ratio of the relative change. So that's absolute change divided by the reference value. We will report this as a percentage, okay? So we'll report that as a percent change. So here I have an example. If Bitcoin was worth $623 in 2016 and is worth $47,538 today, what is the absolute change? What is the relative change? So the absolute change is just the difference. We just subtract them and we find that it's 46,915. What is the relative change? We take that absolute change, we divide it by the old value, we make it a percentage, and we see that it has grown 7,530% in just that time. So that is the difference between absolute change and relative change. Okay. Here's another example. The U.S. population has 298 million in 2006 and 323 million in 2016. Find the absolute change in population. So what do you think it would be? If we have those two numbers, 323 million in 2016, 298 million in 2006, what is the absolute change? We just subtract them, right? So we subtract them, 25 million people. Great. What is the relative change? What is the relative change? Well, we take that absolute change we just found and divide it by the old value. So I find 0.084. That's an 8.4% increase. Okay, that's an 8.4% increase. All right, in this example, we're going to look at CPI. If the CPI was 224.939 in 2011 and 237.017 in 2015, and the tuition per credit hour was 107.8 in 2011 and $133 in 2015. Find the absolute change for CPI. Find the relative change for CPI. So go ahead and pause this video and see if you can't find it yourself. Okay, so let's go ahead and find it together. Subtract, yeah. And I find 12.078. I want to say dollars, but it's not really dollars. CPI is not really a dollar amount, though it kind of feels like it should be, right? Relative change, we take that absolute change and then divide it by the old value. That's what I've done here. And you can see from the arrows, that's where I got my numbers from. I find that that is 5.4% increase. Okay. Very similar question, except now we're going to talk about the tuition. So we're going to find the absolute change in tuition and the relative change in tuition. Remember that the credit hours were $107.80 in 2011 and $133 in 2015. First, find the absolute change, then find the relative change. So pause this video, find the absolute change for tuition, find the relative change for tuition, and then see if we get the same answers. Okay, so for absolute change, we just subtract them, $25.20. Then I take that value, I divide it by the old value, and I find 23.4%. I hope you did too. Okay, awesome. Let's talk about percent change. So it's either going to increase or decrease. Common questions like this are tax and discount problems. A tax problem is really a percent increase problem. For instance, sales tax of 8% would be 1 plus 0.8% times the original value. Or we can take the original value and multiply it by 1.08 to see what the new value would be. So a 99-cent soda times 1 plus 0.8, and then we would find that that is $1.07. Okay, well, that rings true to our experience. A discount problem is almost the same thing, except we subtract. So, for instance, 30% off, it's 1 minus 0.3 times the original value, or times 70%. If we have a 99-cent coffee with a 15% discount, we would multiply the 99 cents times 0.85, and that would give us an 84-cent coffee, okay, with that 15% discount. Let's look at another example. If an item is 15% off, what percent of the original price is the sales price? And part B, if the original price was $50, how much would the sales price be? Go ahead, pause the video, and try to solve this yourself. Come back, and we'll see if we get the same answer. Okay, so we're going to take 100 minus 15. That's 85%, or 0.85 would be acceptable too. If the original price was $50, what's going to be the sales price? We multiply 50 times 0.85. We find $42.50. Hopefully you got the same answer as I did. Another example, you were charged $259 on your credit card for a hotel stay. You are told that there's a 22% tax for hotel rooms where you stayed. What was the original price of the room before taxes? So what must have been the original price before all of these taxes? 22% tax is high, right? So what was the original price? Go ahead and pause the video, see if you can find it yourself. Come back, and we'll do it together. Okay, first I'm going to find the percent increase. So that's 100% plus 22%, or 1.22. That equals, so 122% times some original value equals $259. What was that original value? We can divide the new value, sales price, divided by 1.22, and I find $212.30. So that was the original price, and then the sales price was $259 because of all the taxes. Okay, so hopefully you found the same thing. All right, let's look at another example. 20% of city employees ride the bus to work. This is up from 18% from last year. What percent of employees rode the bus for work last year? Round to the 10th of a percentage. So, again, please pause this video. See if you can't solve it yourself. Come back. We'll solve it together. Okay, let's see if we can find it. What was the percent increase? 100% plus 18%. Then we can plug that in our formula. Percentage times base equals amount. We have 118% times some original value equals 20%. We divide both sides by 1.18. And then we find 16.9%. This was the original amount, the original percentage. Okay. Next up, the interest rate on a car loan has decreased 34.4% over the last 5 years, and now it is 2.5%. What was the rate 5 years ago? Okay, these questions can be confusing because we don't have a value. We just have percentages, right? We have a percentage decrease. We have what the percentage is now. We're looking for what the percentage was before. But it's very similar to the bus problem that we just did. So pause this video, see if you can't solve it yourself. Come back, we'll solve it together. Okay, so percent decrease, 100% minus the 34.4%. Plug it in our formula. We have that percent decrease times the original value equals 2.5. We find it's 2.5% divided by 65.6%, and we find that that is 3.81%. So that's what this example is saying, that the interest rate was 5 years ago. Now it's 2.5. Okay. Let's look at another example. So if you earn $3,200 per month and you expect your earnings to increase by 7.8% per year, how much do you think you'll be making in 3 years? I'm going to go ahead and solve this one right off the bat. You don't have to try to solve it yourself. This one can be very confusing. So because that 7.8% is added each year, this makes it a little bit more complicated. So we take that 3,200 and we times it by 1 plus 0.078, that's the percent increase, and we have to cube that number. That's an exponent. It needs to be multiplied by itself 3 times, otherwise we won't be able to calculate it. So this is equivalent to this. We need to multiply it by itself 3 times, and then multiply it by the principal value. We find that's $4,008.73. Okay, so these can be a little confusing. We're going to see in Unit 2, we're going to come back to this again, this idea of having to use the exponent for that incremental raise. Okay. Have another example here. This one's about bottled water. Consumers are increasingly choosing bottled water instead of less healthy packaged drinks like soda. The BMC data since 2012, bottles has steadily increased in sales volume each year, while consumption of carbonated soft drinks has declined. Bottled water outsold soda for the first time in 2016 and has done so every year since. Americans consume 14.4 billion gallons of water in 2019, up 3.6% from 2018. Bottled water retail dollars sales also grew in 2019, up 5.2%, reaching $34.6 billion. And per capita consumption rose 3.1% to 43.7 gallons. BMC data shows. Now, that source there, if you go to the actual PowerPoint slides, you can click, and I have the link that links to this article, which reports all of that. Now, what I want to do now, how many gallons were consumed in 2018? From the information given, we can calculate this using our percent increase. Okay, so pause this video, try to find how many gallons were consumed in 2018. You can do so from the information given. Okay, so let's see. We plug it in our equation. It's up 3.6%. So that's going to be 1.036. And that equals 14.4 billion gallons in 2019. Divide both sides by 1.036. And we find 13.9 billion gallons of water. Okay. So approximately 13.9 billion gallons of water were consumed in the U.S. in 2018. It's a lot of water. Okay. Next, what were the sales in 2018? Okay, they tell us the sales in 2019. They say they're up 5.2%, reaching 34.6 billion. Go ahead, pause this video, and try to find if you can solve that yourself. Okay, so let's plug in the values. I do my percentage increase. I know what it equals. I can solve by dividing both sides by 1.052. I find $32.9 billion. So approximately $32.9 billion of bottled water retail sales for the U.S. in 2019. Okay, hopefully you got the same values as I did. More examples. Population growth. If Indiana's population in 2000 was 5.977 million and is currently 6.732 million, what is the relative change? So from the information we got before about how to calculate relative change, this should be relatively simple, pardon the pun. Part B, if the percentage change is the same for the next 21 years, what would you predict the population of Indiana to be? Okay, so first find the relative change from today from 2000, and then you can find it from today and then in 21 years. All right, so pause this video and see if you can't find it. All right, so let's do relative change. So here's my relative change. I took the difference of the populations, I divided it by the old, I multiplied it by 100%, I got 12.6% increase. Okay, that's relatively simple if you understand relative change. Now, the part B, this is where we need to plug that in the formula. So we plug this information into the formula. It grew 12.6, so if it's going to grow 12.6 again, we multiply it by the current value, and we find 7.580 million people in Indiana, and I guess that would be 2042, right?